So members, now we are going to see how we handle complex numbers which are purely real and those that are purely imaginary, but please don't forget to subscribe to the channel. Now, a complex number is said to be purely real if it's purely real. It means that it has no imaginary part because it's real, purely. It means that if it's purely real, its imaginary part is zero. When I look at this complex number x plus iy, if it's purely real, it means that the imaginary part is zero. And if it's purely imaginary, it means that the real part is what? Zero. So find the locus of this complex number if it's no matter purely real or imaginary. What we do, we now express this into the real part and the imaginary part. First of all, we let out the z be a complex number. So from here, if I put here x plus iy, I group the real alone and the imaginary also alone. So if I put there, start this will be now x minus 2, the real, then plus I into y minus 3, the imaginary. If I put them there, then over, the real here is 1, so it will be x plus 1, then plus I, y. But we say, in all we do, we don't want I in the denominator. So what we do, we rationalize this by multiplying by the conjugate of this number, both sides, and then up and down. So the conjugate will be then also up, the same with the conjugate. So that's what we do now. From there, after we expand, you see that I'll be having this times this, I'll be having this multiplying this, and this multiplying this, then plus this multiplying this, and that. So we now having into, then this now multiplies this, I'll be having minus I into x minus 2 multiplying y, this y. Then still this times this, I'll be having now plus I into y minus 3 to x plus 1. Then this and this is that a negative and a negative, I'll be having negative I squared. Then y minus 3 into y. The whole thing over. Now we'll see, I said the difference of two squares. I have x plus 1 square. Then when I square this, I have 9y the whole square. The difference of two squares. So let us expand up and see what we have. I have this and this. X squared plus x minus 2x minus 2. Then this will give me minus I xy, then plus 2 yi. Then this will give me plus, this and this will give me I xy. Then this and this will give me plus I y. Then this will give me minus 3xi. Then this will give me minus 3i. We said I squared is negative 1. I squared is negative 1. This is negative will give me now a positive. Now this will be positive. Then plus y squared minus 3y. The whole over. When you square this, you get x plus 1 squared. When you square I, you get a negative 1. Now this negative 1 plus, now to give us a plus y squared. Now, you see that this one is cancelling with that. Up we have now. Now we group them into the real and the imaginary. So the real I don't without I. That is without I have x squared plus y squared. This and this will give me minus x. Then, this I have here, minus 3y. I think then minus 2. So I have minus 2. That's the real part. We divide it with, of course, this is the denominator, which is x plus 1 squared plus y squared. Then I want the real, I factorize out I. If you factorize out I, you see that here, I'll first of all be having 2y plus this will be having 3yi. So if I move I, I'm even with 3y. Then this will be negative 3x. When I move out I, I'll be having now this. Then this will be minus 3. The whole over, still the denominator is x plus 1 squared plus y squared. So start I've separated it into real and the imaginary. So now, if I'm to handle part A, which says purely real, it means that the imaginary of z is equal to 0. So that this is my imaginary. Real means that all of this is 0. So now 3y minus 3 over squared plus y squared is equal to 0. First multiplying, so that we have 3y equal to 3x plus 3. So my y is x plus 1. So if it's pure real, what you get is a line. You can describe it if you want. Then part B, if it's purely imaginary. Imaginary, let us say if it's purely imaginary. If it's purely imaginary, it means that it's real. The real part of z will be 0. So now it means that this is our real part. So when this also I have x squared plus y squared. The whole over x plus 1 squared plus y squared is equal to 0. So in the first multiply, we have x squared minus 3 equal to 0. And the sum members, this is a circle. So the locus here is a circle, the locus here is a line. You can go on to describe its center and the radius as we saw in the previous video. So members, that's how we have numbers when they say pure real and pure imaginary complex numbers. I wish you the best, but please don't forget to subscribe to the channel.